Hi everyone, my name is Alex and this is my tutorial on the Raspberry Pi and how to turn it into an audio sampler. And I'll be showing you also how to manipulate the sound, specifically the pitch and tempo of WAV and MP3 files using the Sensat here. Not much is needed for this tutorial setup, basically just the Sensat which mounts on these pins here on the Raspberry Pi 3 itself. On the Raspberry Pi you'd need an SD card with the OS Happy Brackets installed, a connection to an external monitor for just seeing that the OS is installed properly and running, and a connection to powered speakers for getting audio out of the Raspberry Pi, and lastly just to power the Raspberry Pi a micro USB connection to an AC adapter or even just a portable phone charger. Attaching the Sensat to the Raspberry Pi is pretty straightforward. Just line it up with the pins on the PCB itself and it'll just snap in and it'll be ready to go. To get started with connections, first connect your micro USB power connection, then HDMI, and then your powered speaker. Though you can connect a keyboard and mouse to the Raspberry Pi, this isn't necessary as all the programming is done on another computer via IntelliJ, which is connected to the Raspberry Pi over a Wi-Fi connection or Ethernet. Before powering on the Raspberry Pi, it's important to set up a network that the Raspberry Pi and your computer can communicate across for programming. The best way to do this is to set up a Wi-Fi hotspot on your phone. So set the network to PiNet and the password to Happy Brackets. That way, when you power on your Raspberry Pi, it'll automatically connect to this network. So once you power on the device, you'll get the Sensat light up and you should get all this code loading up. Don't worry about this. This is just the OS booting up, and once it's ready, you should hear 3 beeps. So once you've confirmed that the OS is booted up and working, we no longer need the HDMI connection. Okay, so this is the software part of the tutorial. Basically, I'll just be using 2 programs. First is IntelliJ, which is the IDE for programming Java, and this will also be used for sending code to the Raspberry Pi over the Wi-Fi network. Secondly is WinSCP. Now, I'm using a PC, so what WinSCP is for is just copying files, in particular the samples, the WAV samples that we want to use, copying them directly to the Raspberry Pi without having to use the command line interface. Okay, so I've just jumped into my project file straight away here. Before we get started on the explanation here, firstly you just have to install the Happy Brackets plugin, which you can find online. Just install that, add it to the IntelliJ IDE. This will allow you to send your project over the Wi-Fi network to your Raspberry Pi, which you should see here once you've connected it to a Wi-Fi network. Basically, to test the Raspberry Pi, just click this B button here, and if you hear a sound like so, that means your Raspberry Pi is connected to the network and your computer is able to communicate with it. Okay, so first off, we define how many audio channels the device is using. In this case, we've just put 1. We then define how loud we want the sound. By default, the sound is usually quite loud, so it's important to define that. We then define the sample name here. So this directory and file name here is a directory and file stored on the Raspberry Pi's SD card. And I'll show you in a bit using WinSCP how you can just drag and drop files from your computer to the Raspberry Pi's SD card in order to play back those samples. We then create an actual sample here. We then test if the sample opens successfully. So this is important. If the file is missing or corrupt, you'll get an error message and you get a failed to load message here under your devices when you send the composition through. We then connect the sample player to audio, so that way we can actually get a audio output to the HDMI or headphone jack on the Raspberry Pi. We then set the sample to loop. By default, the sample doesn't loop, so it's important to define that and set that up. And finally, we define the accelerometer parameters. So the Sensat is defined here, and depending on the axis of tilt, the sample's playback rate will be manipulated. Okay, so here I'll show you how to remotely connect to the Raspberry Pi to add files to the SD card. Basically using WinSCP is easier to just doing command lines. So basically you get the IP address of the Raspberry Pi. It'll tell you once the Pi is booted up what it is. In this case, for me, it's 192.168.43.67. Leave the port number and everything as default. The username is Pi and the default password will be Raspberry. And then you hit login, it'll connect, and you'll see the directory of the SD card here. So I put the samples in Happy Brackets and data audio, and all you have to do is just drag and drop your samples or whatever you want. Just drag them in. It'll copy it to the Raspberry Pi, and that way in your code, when you're defining the directory and file name, you can type in the directory and the file name of the sample that you want. So once you've got your code and Raspberry Pi set up, all you have to do is go into your IDE, right click on the project, and click Send to Device. The Raspberry Pi will start to output audio via the speaker. And once I pick it up, the accelerometer will modify the sound. When I tilt it this way, the speed and tempo increase and the pitch. When I tilt it back, it decreases. And when I flip it over, the sample is reversed. I'll do a demonstration now with some drum samples that we loaded in the sample folder. So in order to change to the other samples we had in the folder, simply go up to the define our sample name here, the final string sample name, and all you have to do is change this last bit of the file name to the other file names. So I've got a tech drum like so, so just type in tech.web, that's the file name, save that and recompile. Over here you click refresh composition folders, and then you can send the project to the device. And the drums will start playing. And the sound manipulation is the same. Powering the Raspberry Pi with a portable power bank and connecting it wirelessly to a Bluetooth or wireless speaker, coupled with the infinite amount of effects including filter and decay, would make it the ultimate live performing machine. The possibilities would be endless.